So I'm just doing this video as a little extra practice in recognizing functional groups. So what I'm going to do here is just pull up some molecules, pause for a second, let you try to think about, try to identify all the functional groups that you can, and then I'll point out all the ones that I recognize. When doing this, it might help if you have this this little page from your guided notes out. These are going to be the functional groups that you would be responsible for recognizing. So let's get to it. Okay, so first take a look at this molecule here for a second and see if you can count functional groups. I can count 1, 2, 3, 4 different functional groups from the list that you should be able to identify here. Okay? All right, so let's identify them. All right, first off would be this guy right here. This would be a hydroxyl. A way of knowing that it's not a carboxylic acid is you would have to have a carbonyl, a carbon double bond oxygen on the carbon right next to it. So since you don't have that, this is just a plain hydroxyl. This right here is an amide. All right. So you've got the nitrogen, and right next to it you've got a carbon double bond oxygen, or another way of saying it, that's a carbonyl. All right. So because you've got a carbonyl right next to that nitrogen, that makes it an amide. All right. This right here is an amine. All right. And there's a question about how do you know it's an amine versus an amide. All right. Well, check the carbons that are right next to that nitrogen. Neither of those are carbon double bond oxygen. Neither of those are carbonyls. All right. So because of that, this would be an amine. All right. And the last one that I can recognize here would be this group right here. And it might be a little bit difficult to recognize because they don't draw on the carbon right there. But if you recognize that there is a carbon right there, that carbon triple bond to nitrogen, that would be a nitrile. Okay. Next we'll show, this is beta carotene, all right, and see if there's anything on this that you can recognize. All right, so the only thing on this that really stands out to me is that this would be considered an alkene, all right. You notice that there's a lot of double bonds, all right. You see a lot of these CH3s, those are called, those are methyl groups, all right, and a methyl group would be considered an alkyl group. All right, so you could say that there's a bunch of alkyl groups off of this alkene. All right, and one thing I just want to point out about this, notice that the location of the double bonds. Notice that there's a double bond, single bond, double bond, single bond, double bond, single bond, and there's this alternating pattern. One thing you'll find out is that's actually what helps to give compounds their color. All right, anytime you have a colored compound, you generally have that alternating pattern. That's called conjugation. All right, you're not responsible for knowing that right now, but carotene has got an orange color that comes from that arrangement. Okay, so this is ibuprofen right here. Take a look at that, see what you recognize. All right, so a couple things that I recognize on this. This part right here, that would be considered a benzene ring. If you're calling it a substituent, you would call it a phenyl group. All right. Altogether, this part right here, notice that this is all single bonds. All right. So if you want to describe this group right here, that would be considered an alkyl group. All right. Again, that's using it as when an alkane is described as an adjective, you call it an alkyl group. All right. And the last thing I could find here, this part right here. All right. So ask yourself, this right here, this OH, is this a hydroxyl, or is that the OH of a carboxylic acid? All right. So this would not be a hydroxyl. All right, and that's because it is connected directly to a carbonyl carbon. All right. And that makes this entire functional group right here a carboxylic acid. All right, so again, this entire thing is a carboxylic acid, but you could say that the carbon double bond oxygen is the carbonyl group within that carboxylic acid. Okay, so this is aspartame. all right, which is an artificial sweetener. It goes by the trade name NutraSweet. So see what you can figure out there. All right, so right off the bat, this guy right here, that is a carboxylic acid. All right, again, that would not be considered a hydroxyl right there. Right. This group right here, that would be an amine. All right. The way that you can tell that it's not an amide is that if you look at the carbon that's directly attached to the nitrogen, that would have to be a carbon double bonded to an oxygen. All right, and you don't have that, so that makes that just a plain old amine. All right. In contrast to that, take a look at this guy right here. All right. That nitrogen has got a carbonyl carbon right next to it. Right. This is a carbonyl group. Right. So this is the carbonyl group of a functional group, which we consider to be an amide. All right. So the functional group is the amide, but there is a carbonyl within that amide. All right. And this guy right here. All right. That guy would be an ester. All right. Again, it's not, it's, you might look at that and see, well, carbon, oxygen, carbon, why isn't that an ether? And it's because this right here is a carbonyl group, all right? In order for it to be an ether, this can't be a carbonyl, all right? And the last one, this right here, that's a benzene ring, but if you wanted to name it as an adjective, you would say that it's a phenyl group. Okay. So taking a look at this guy right here, this is actually both an alkene and an alkyne. All right, so it's an alkene because we've got this carbon double bond carbon right here, but it's an alkyne because you've got this carbon triple bond carbon. All right, some people would call this an ene-ine. That's just a combination of the terms, but both of those groups are present in this molecule. Okay, taking a look at this one. All right, so ask yourself, I see this this NH right here, so is this going to be an amine or an amide? All right, and remember when I say amide, that could also be considered a carboxamide. All right, but typically people just say amide. All right, so the way to tell the difference is what you look at the carbons right next to it. All right, and if either of them are a carbonyl, that makes it an amide. And so since I have that here, this whole group right here is an amide group. All right, this would be a benzene ring right here. And here you've got carbon, oxygen, carbon, and neither of the attached carbons are carbonyls, so that makes this right here an ether. Okay, so this one right here, this is a drug called prednisone. It's used to control inflammation, there's actually there's a functional group that we haven't talked about yet, and I can give you a hint. If you think about the name prednisone, there's a root in that word that might give it away. All right, so that functional group is going to be a ketone. All right, notice that the name of the drug prednisone ends in that. Another drug that's molecule that's similar to this is testosterone. All right. So a lot of times when you hear these things that end in O-N-E, that's going to be a hint that there's a ketone somewhere in there. All right, so here is where I can find a ketone. Here is another ketone. All right, and notice that in order for these to be ketones, if you look at the carbons right next to that carbonyl carbon, these guys can't be, this right here, first of all, it can't be an oxygen. All right, if there's an oxygen there, that would make it an ester. You don't have that at either of the positions, and there's also not a actually that would be the only requirement. So that's a ketone. This is a ketone right here, and these two things, these would both be hydroxyls or hydroxy groups. Okay, so this molecule right here is morphine, and there's several functional groups in this. Take a second, see how many you can locate. All right, so first of all, I can see this right here. This would be a hydroxy or a hydroxyl group. Same thing down here. And again, if you looked at that carbon that it's attached to, that's not a carbonyl carbon. Neither is this one. That's why it's a hydroxy. What about this right here? You should be able to identify that. All right, that would be an ether. All right, that's an oxygen that's got 2 carbons on each side of it, and neither of those carbons is a carbonyl carbon. All right, the last group would be this one right here. All right, that would be an amine. All right, so again, none of the carbons that are directly attached to the nitrogen are carbonyl carbons. That's why it's an amine, not an amide. All right. This might look a little strange, but like there's actually a couple rings that are kind of fused to each other here. So this is actually this part right here where it's really bolded. That's actually a ring that would be almost like coming out towards you, like it's 3-dimensional. All right. But anyways, that's a carbon right there. That's an intersection right there. That's a carbon right there, and that's the 3rd carbon. So that's an amine. All right. One last thing I wanted to mention about this, just like with testosterone, the last syllable in that kind of gave away a functional group that it's got. Things that end in -ene a lot of times end up being amines. All right. So again, this is morphine. All right. That's a hint that there's probably an amine somewhere in the molecule. And just as another example of that, this is amphetamine. All right. So again, it ends in -ine, and right there, that's an amine. All right. So in case you're looking at this, you should be able to name this part. All right, that would be a phenyl group, or if you're calling it as a noun, that's a benzene ring. All right, this right here, this methyl group, that would be considered just an alkyl group. All right, because it's all single bonds. All right, so I can't tell you the name of this one because it would give it away. But a couple groups. This would be a phenyl group. All right, or you could call it a benzene. Since you've got most people would not call this an alkene. Technically it would be because it does have this double bond. All right, but what about this guy right here? All right, so notice you've got this carbonyl group. All right, but we've got lots of things that contain carbonyl groups. We've got amides, we've got esters, we've got carboxylic acids, we've got ketones. Which one is this? This guy is an aldehyde. All right, notice that this thing here, that's carbonyl carbon, and this isn't a hydrogen right here. So the name of this guy is cinnamaldehyde. All right, it's the molecule that's responsible for giving cinnamon that flavor and odor. All right, this is something very similar to the last one I just showed you. All right, and take a look at this. All right, so the last one was an aldehyde. This one is a carboxylic acid. All right, so since this is an OH and this is a carbonyl, this entire functional group right here would be a carboxylic acid. This is called cinnamic acid. All right, it sounds like cinnamon. You just change the stress on the word when you say it. Cinnamic acid. Okay, another molecule that's very similar to the ones we've just been looking at. All right, there's now something a little bit different here. All right, so instead of this being an OH, this is now an O, and then you've got, this would be a methyl group. All right, so this is an alkyl group attached to the oxygen, this is now considered an ester. All right, but again, this is the carbonyl group that's part of that ester. All right, and just like the one that we showed before, the carboxylic acid, there is a carbonyl group that's part of the ester functional group. All right, but you call the whole thing, this whole thing would be considered an ester. All right, so just one last one. This is fructose. All right, and hopefully you recognize fructose as a sugar. All right, and the one thing that you're going to recognize, and this is going to be true about all sugars, is that you have hydroxyl groups all over the place. All right, if you look at the structure of glucose, which I'll do here in a second, you'll notice the same thing. All right, it's actually the presence of all these hydroxyl groups which gives it that sweetness. All right, so this is glucose right here. It's drawn a little bit differently than you might be used to seeing, but notice that you've got the hydroxyl groups all over the place. One other thing that you might notice about this and fructose, this part right here, that would technically be considered an ether. All right, so just one last sugar. This is sucrose. All right, so this is table sugar. And again, you'll notice that there are hydroxyls all over the place. And Again, that's what's responsible for the sweetness. And you could say that there's a couple of ethers. In fact, this would be considered an ether.